Hello everyone, welcome back to Understand. I guess we're moving on to World 2 here, having mastered World 1. Don't totally understand why the indicators are in different places here, but whatever. I'll jump right in. It's telling me to draw this, that's fine. What if I did that though? That's allowed. So far it seems like the rule is start at any circle, go to a square. But that's not correct. Starting here is fine. Starting here is fine. Start at a square, go to a circle. Okay, start at the most common shape and go to the least common, I guess, is holding these together. So like that. Is it okay if I touch other things? Yeah. Ah, why would you make me do this? Okay, we said we're starting at the most common, going to the least. I see a lot of squares and only one of these guys. Okay. This time it's saying circle to circle. Ooh. Didn't get any points for that, not even one. So it's not about starting at a circle specifically. And I want it to end there. What are the two constraints? It's hard to meet only one, apparently. Oh. I see. So filling the circles is one constraint and not filling the square is the other. It doesn't care where I start. Okay. So this world, this like whole 2-x-x so far seems to be about counting. So we seem to be doing something like this, right? Fill up the most common and don't fill up the least common. And it doesn't care about the middles? It does. Okay, fill up the most common, don't fill up anything else. Okay, seems fair. Squares and triangles are tied, so fill them both up, perhaps. Okay. No, that's not right. There's 3 squares. There we go. There are 2 stars, 2 of everything except circles and triangles, so we do that. Oh, it's red down there. All right, 2, 3, please. Go from the circle to the square. Why? Get 1 of every shape? So far, so good. That hypothesis holds. Okay, I think I'm getting the idea of this world. Okay, I guess that was a simpler line. Okay, easy. Oh, 3-1, but I love going through levels and just like getting a concept down. Go through everything. Not sure why yet. Go through all the 1 shapes, perhaps? No. Go through all the shapes? No. We started a circle and we went to a square. Go through exactly 2 triangles? Okay, triangles like to have 2 of them. And 1 of everything else, or does it care? So this is kind of interesting. This is allowed. This isn't. So clearly we want exactly 1 circle. And we also seem to want exactly 1 square. So why then does this still give us 2 marks? Are triangles not special? Could I go through 2 of something else and only 1 triangle? No. Ah, yes. Why? So it seems I have to start at a circle. That's rule 1, right? Yes. I thought I'd get points for going through 2 triangles there. So this first one is started on a circle. The second one seems to be end on a square. The middle one, I'm not sure yet. Sorry. The second one is end on a square. The middle one I do know, of course. That's the second one. What I don't know is the last one. And I assume that's the one I violate here, right? And going through 2 triangles fixes it. But not unless I actually end on another shape. So this actually gives me the third one. So it seems we start at a circle. Then the second rule is end on a square. The third rule is go through 2 triangles and then end on some other shape. Now we know that's not quite right because it doesn't fit the testing we did on 2, 4, 3. But that's getting closer to the right idea. Right, because we're allowed to do this. Okay, so end on a square is still required. That's allowed. That's allowed. So have exactly 2 of exactly 1 shape. But then why isn't this okay? Oh, wait a minute. Have 4 shapes. Aha! Have exactly 4 shapes. It doesn't care about triangles at all. Well, I knew it didn't once I saw this other stuff here, but it doesn't care about going through 2 of something. So I could do this, I think. This is basically the same as what I did on the last one. So there's no real other way to test my hypotheses yet. Okay. Now I could do this. That should work. And I think this would also work, right? Yeah, 4 shapes. Start at circle, go through 4 shapes, end on square. All right, that's a cool little trick. I didn't see that coming. But I mean, I don't know, I guess World 2 is all about counting things somehow. Square to square, okay? How about circle to circle? The first rule seems to be to start on a shape. Doesn't care what shape. Second rule... It's a little complicated, actually. It's not end on a square. It's not end on the same shape. Maybe it's go through 4 things? Hang on. I don't even get any points for starting on a square this way? Start and end on the same shape? Okay, start and end on the same shape and have 4 shapes. That's my current hypothesis. So we could do that like this, for example. No good. Huh. What's different here? What's the second rule that I'm... So the first rule is start and end on the same shape. We're pretty happy with that, right? Yeah. And we thought that the second rule was go through 4 shapes, but it doesn't seem to be, because this is allowed. So what's different here? Only straight lines? Yes, only straight lines, no bends. Okay, that seems good. Squares require straight lines and circles require bends or something? Something like that. I can't... Well, this would get 0 rules, okay. Triangles? Oh my god, you're gonna make me learn about triangles, huh? So this would be starting and ending on the same shape. And so would that. Right, that's start and end at the same shape. We're pretty confident about that. Don't do that. So what? What? So a right side up triangle has to be part... No? Excuse me? How are these different? Has to do with the shape of its neighbors? Huh. Is this okay? No, right? Okay, so there's symmetry here in that those two are both allowed. So my working hypothesis for this is not very good. But my idea is, what if right side up triangles, when they're part of a shape, right, we sort of determined that this world is about shapes made by the line passing through the shapes drawn on the board. So here, square to square requires a straight line. These circles are actually really puzzling, because I thought I showed here that circles want a kind of bendy line, right? Actually, what if I did like this? Yeah. Circles want a bend near them. Circles want a bend anywhere. No? Can I do this? No. So this, I think, is no good. It is good. Why? This is all fine. Does each circle give the line permission to make some number of angles? Right, like here, the number of angles in the line is 2. Here, it's 3. Likewise here, 3, and here, 3. But if I do this, the number of angles is 1, 2, 3, 4, 5. And that's not allowed. Maybe? But there also has to be at least... On here we can do, yeah, 3. We can't really do 4, I don't think. Can we? 1, 2, 3, 4. Yeah, but I don't remember if that's bad just because it's going through the square or what. Okay, so going through this other circle was a red herring. What if I went through more of them? I went through lots of circles. Could I have more lines? More bends? I don't think so. So 3 bends seems to have been allowed before, but isn't now. Maybe the circle can't itself be part of it. No, it can here. I don't understand the circle rule or the triangle rules. We know squares like straight lines, I thought. I can't explain this. I thought squares like straight lines. Is there some way to make this not about the lines, the shapes at all? Wait a minute. Are you asking me to draw a line of a particular length? Here there are 5 gray squares. Here there are 5 gray squares. Or not gray, but filled in, whatever. And likewise here, 5. If I add another, too many. Here, 5 gray squares. I don't know. I'm a little bit gray-green colorblind. I think this is supposed to be a little bit greener than I think it is. Here, okay, not 5 gray squares, but 5 in between the start and the finish. Here, 5 between the start and the finish. Of course, this world is about counting things, silly. Counting. And we couldn't ever do it with the right side up triangles just because they're all even numbers apart from each other, right? So there's no way to get from one to the other in 5, or, well, yeah, 1, 2, 3, 4, 5, 6. I guess the line is of length 6. Sure. Wait. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why doesn't that work? It does work. I just didn't try that shape. Okay. Got it. That explains this. And is there any other way to do it? Not real. Well, that? Yeah, okay. One, 2, 3, 4, 5, 6. Okay. Must be a lot of solutions to this one. But I don't want to have to count them. How about that? There you go. What? It lit up, but I still wasn't allowed to leave. That's weird. Should I use a different shape? It's impossible with circles, and I think it's impossible with squares also. Yeah. Maybe do them all. Oh, that's too... Is it possible to do them all? I don't think so, right? Oh, first of all, that wasn't even a try. 1, 2, 3, 4, 5. Right, that's no good. Oh, right, you can't do it with the circles. So can I do it with... And I can't do it with both of these shapes either, because there's a kind of line in between them. You end up blocking one if you take the other. So I can't get to both stars from one of these weird octagon. It's not an octagon, but it's kind of like got 8 points. I can't get to both stars this way. And likewise, if I start at a star. So this doesn't allow me to advance for reasons that I don't understand. And it does say I haven't finished it, so it's not like... I don't know, I'm wondering what is going on here. We clearly don't want to do that. This is all nonsense. Huh. I guess we'll just have to skip ending 2-5 for now. 2-6. It says go this way. Yeah, okay. Ooh, interesting. There's 2 different rules. One of which is violated by going through the square, and the other which is violated by not going anywhere. So start at the most common, don't touch the least common. We had one like that before, didn't we? There must be some twist this time. Oh no, we had one that was like start at the most common, go to the least common. So now I guess we're meant to go to everything except the least common? No. So of the available shapes, choose the one that has the second fewest and just go through it. That would be triangles, but there's no way to do that without going through other shapes. I thought maybe the shape that's most common you might be allowed to go through. That's why I tried this. And that does appear to satisfy some rule. But look at this, going from triangle to triangle isn't even helping us. What? How can we reconcile what we know? Oh. Go through all members of each shape that has an even number of elements represented. So here, that would be squares and triangles. Okay, got it. But I can't do 2-5. 2-7, huh? Leave an even number of each shape on the board, perhaps? But then I could do this, couldn't I? Okay, can't quite figure out what the rules are from that. Something about counting something, presumably. matters which one I start in versus end in. So this would be illegal? Leave 2 of what you started in and erase everything else? Well, not erase, but cover. Okay. Can't be done here, can it? Oh yeah, no. Huh. This is no good, right? Yeah. Ah, is it about start at circle, end at square again, but then some additional rule? No, because I started at star this time. Starting at star, ending at square here. Start at the most common, end at the second most common? Maybe? And then something else about what you do along the way. This satisfies whatever the other rule is, huh? Wait a minute. What the heck is this? Fill exactly half of the shapes? Well, on this level there are 7, so that seems difficult. This satisfies the third rule. Okay. So it matters how you get there again. A line of length 3? While starting at the most common and ending at second most common? Or at square? Okay, and circle and square are tied here, so they're both valid endpoints. I could do this, right? Yeah. Ah! The sideways triangles, please! They're killing me. I hate them. They look awful. It's just the whole thing looks so jumbled and messy. Okay, well, which shape is most common? How many right side up triangles? We have 2. How many upside downs? 1, 4. Oh, they're neatly organized, I see, by diagonals. So, according to my previous understanding, it would be this. No. Did I have to end at square? Could I have ended at circle? No, I couldn't have. And what I did in the middle doesn't seem to matter at all. Could do that, yeah. Can't do this, because there's no way to get length 3 and still end on the right shape. Could do that, though. So it seems like starting in the most common is pretty important in all of these so far. It could be started in what there's 3 of, I guess. We've done that every time as well. Okay. Start at what there's 3 of, end on what there's 2 of? Sure. So we're starting at squares and ending on these things. Seems good. Okay. 2, 9. I'm a little annoyed about 2, 5 still. Ooh, 4 rules. Not allowed to do this, huh? You could go the other way. They're both equally good. Oh, look at that. These are breaking different rules. Oh, start and end on the most common and also do something else? Right, the second rule should be the only one that lights up here, probably. Nope. Well, the first one didn't. Yeah, and so I think the first 2 rules are about starting and ending on some shape, probably the most common. And the third and fourth rules, I don't know. Really. So touch no other shapes and have a line of length at most 3? Seems plausible so far. Yeah, okay. Those could be our rules. But then it would be impossible to solve this puzzle. What? Have a line, have an odd number of, no? Have an odd number of these squares? Is that right? No, because we can do this. Okay, so it's not starting and end at the most common. It seems to be about circles. Now, the inside the third rule is touch no other shapes, right? Yeah. And it does seem to be about parity of the length of the line. I assume that like this doesn't work, this doesn't work, this doesn't, but this will. We made it a line of length 6 with therefore 7 total filled in squares. Here there are 5 filled in squares. My question is, why is this allowed with 2 filled in squares? It doesn't seem to be distinguishing between squares used and squares, like, I thought maybe, okay, in this time we have an even number of used squares, this time we have an odd number of used squares. Maybe there was some difference in the number of unused squares, but it's even here and odd here. Huh. Yeah, and that's allowed the same. Got 3 squares left out. Don't know why yet. This should be okay, right? No. Why? $12 filled in squares, 2 filled in squares. Oh my god, is this about prime numbers? 3 filled in squares. 2, 5, 7, 3, 6, 11. Oh, you guys think you're so funny. 2, 3. How could I do 5 to prove that? This would do it, right? I see. Can I do 7? Not if I use this one. Can I do it from here? It should be possible, right? Yeah, just add these two. I see. How would I do 13? That's all but 3 of them, right? It's a little bit harder. Well, 11 is a prime in between those two. Oh, but I already proved 11. That's right. In a previous puzzle. So all but 3 would look like that. I see. Got it. So here I have, what, 18 to work with? I could use all but 1, for example. Okay. We're still meant to go through no other shapes, right? Right. How big is this grid? 11 by 5 is 55. So the number that I must have to go this way is 11, 22, 25. So next prime would be adding 4 useless ones to this, which would look like that. Hang on, that only adds 2 useless ones because we cut 2 out. So we need to go like that. Okay. I see. Can I? No, that's 4. All right, what are the gap lengths I have to work with? 4. Now I can't quite count them in terms of gaps because passing through a square and starting on it use up the same amount. Okay. So from here to here is 4, 5, 6, 7, 8, 9. Plus 3 would have been 12. That's no good. 1, 2, 3, 4, 5, 6, 7, 8. Plus 5 is 13. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted wrong by a lot. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5. It's tricky though, because I can't just say, how can you add together numbers, 4, 8, 10, and 5? Because as I said, starting at, I mean, it's easy, I guess, to just do this by like trial and error, right? Like you could choose all the legal start points and go to all the legal end points, and it's honestly going to be easier than just doing the math. There you go. See, I knew it was right. I guess another thing I could have done, I don't know. This is fine. All right, it gave me 2, 8 anyway. Interesting. I think I'm gonna call a break here though. I'm not gonna finish all of World 2 apparently in this video. So I hope you guys have enjoyed. Thanks for watching, and I'll see you next time.